Okay, warm-up quiz. As always, sometimes I sneak in a problem where there's two correct answers. If that's the case, your best bet for maximum points is to go between the answers. Okay, if there's one correct answer, then to go for that answer. But again, you can pick anywhere. All right, here we go. Question 1. So identify the physics model that best describes this diagram. And here's a hint. Something that has an unbalanced, that's meant to be force, will also be accelerating. But if the diagram is a force diagram, the best choice would be the unbalanced force model. All right, so there's your diagram. What physics model best describes that diagram? Give you, if you need a few more minutes to think about it, pause the video, move on to question 2. Identify the physics model that best describes this diagram. Again, pause. And I'm moving on to the next question. Okay, which of these correctly, so I've copied and pasted the formula sheet, and which of the ones that I've circled identifies the formulas associated with the uniform acceleration model? So which of the formulas I've circled are the ones that correctly are associated with the uniform acceleration model? So pause, think about it, and moving now on to question 4. A cat sitting on a slope roof, there's the forces. Which of these vector addition diagrams is correct? So when I put the forces together as a vector addition diagram, which is correct? Right, pause just to think about that one. And I'm going to move on to the answers now for question 1. So here a car's accelerating. So obviously the uniform acceleration model. It also has an unbalanced force, but we're not given any information about forces or mass or anything like that. So definitely the best one to choose at this moment would be the uniform acceleration model. There's two forces on this block. When you put those two forces together in a vector addition diagram, what you get is one down and one here, and the overall, it's an unbalanced force. So it's definitely the unbalanced force model. It does accelerate, but you're given forces. So that's why this is partially correct. It does describe it, but it's not the best description. The best description is the unbalanced force model for this one. Which identifies the formula with the uniform acceleration model? The key is this first one is constant speed. Okay, so that's why that's wrong. You can see these ones all have acceleration in them, right? And so it's these 5 and this last one here that are all useful for the uniform acceleration model. You can choose which one you're going to use depending on which variables they give you. So for example, if they don't give you t, then you'd use the last one. If they don't give you d, then you use this one. And the last one is a good old tricky question. When you put those together, it depends on which order you draw them in, because there's 2 right answers here. So this one I've drawn the gravity down first. There's my gravity down, and I've drawn it here. And then I've done head to tail, I've done the normal force, which comes up, and then I've done the friction force, and it gets back to 0. This one here, I've started with the gravity force down. I've then gone with the friction force next, and then the normal force. These triangles are equivalent, okay? And it depends on which one you like using. They're both the right answer. So the right answer for maximum points is in the middle here. All right, well done.